Hi guys, this is Mrs. Brownstone. Today's lesson is going to be about systems of linear equations, elimination with change. This is Learning Target Unit 4, Target 1C, Part 2. So the first thing we're going to want to do is we're going to look at the system below. What method would you think to use when looking at it? Hopefully you said elimination, but why? Why elimination? What tells us that this system is supposed to be done by elimination? What hopefully strikes you as the reason why we do elimination is that this is lined up in columns. And what do I mean by columns? The x's are on top of each other, the y's are on top of each other, and the constants are on top of each other. That right there is stereotypical of an elimination problem, and we have that here. But this method will not work based on the skills that we practiced in the previous lesson. And why is that? We do not have opposite-like coefficients. So we're going to need to do something in order to be able to use elimination to solve this system. We're going to need to change the way the system looks in order to be able to do that. So next, we're going to look at this little activity to help us understand how to change a system. We're going to want to find a solution of the linear equation. And as a reminder, a solution is an ordered pair which makes the equation true. So for simplicity's sake, we're going to pick an x value. Let's pick x equals 1. What I'm going to want to do then is I'm going to want to go ahead and I'm going to want to substitute x equals 1 into the equation. Simplify that equation down to get that y equals -1. Always make sure that you write your answer as an ordered pair. So in this case, our solution to our multivariable equation is 1, -1. Next, we're going to want to multiply the entire equation by 3, the equation over here. And we're going to want to use that Cannon method. Make sure everything gets that 3. When we multiply by 3, we get this equation here. 18x minus 9y equals 27. Next, we're going to want to go ahead and substitute that ordered pair that we found above into our new equation. When I simplify that down, I get 27 equals 27. That is a true statement. Therefore, we can make the conclusion that the ordered pair, 1, -1, is still a solution of the equation. So what conclusions can we make from the activity that we just did? Simple. That multiplying an entire equation by a constant does not change its solution. So now that we understand that multiplying an entire equation by a constant does not change its solution, we could go ahead and apply this in the context of elimination. Changing the way a system looks to use elimination is going to be very similar to what we just did. As you can hopefully recall from the previous lesson, the first step we learned to solve elimination was to arrange the system into columns and then add. So if we want to solve a system using elimination, we have to make sure that we have variable terms with coefficients that are opposite-like terms. Now, what do I mean by opposite-like terms? An example of this would be positive and -3. They are the same number, but they have opposite signs. Or -7 and +7, same number, opposite signs. So we're going to have an opportunity here to practice this. We're going to want to use multiplication to change this system so that at least one of the variable terms are additive inverses or opposite-like coefficients. Now hopefully you realize here that there are the same system written three times. You can change the system in many ways. So I'm going to demonstrate 2 ways to do this, and then that third way is going to be an opportunity for you to do this on your own. First, I'm going to want to try to make those y values be this opposite-like coefficients. I notice that their signs are already opposite, so I just need to make that top y the same number as the bottom y. 3 times 2 is going to give me 6. So when I multiply that top equation, I get 8x minus 6y equals 20. I rewrite that bottom equation because it didn't get changed, and I was successful. My y's have the same number, opposite signs, or opposite-like coefficients. In the middle column here, we're going to want to make those x's opposite-like coefficients. Right now I notice that their signs are the same. That means that my multiplier is going to need to be negative in order to change the sign. What I'm going to want to do is I'm going to want to multiply that bottom equation by -2. That leaves my top equation exactly the same. And my bottom equation becomes -4x minus 12y equals -40. Again, I was successful. My x's are the opposite like coefficient. Same number, different signs. So now that you've seen this done two different ways, use this third column over here for you to try. My hint is that you're going to have to multiply both equations this time. You try. Pause the video. Try this out. Check with somebody in class, a friend, me. Make sure that you understand this very important step before moving on. So hopefully you were successful. Everybody can have a different answer here, which is why I did not fill this in. Make sure that you've checked this third change step before moving on to our system steps here. Now there's going to be 7 steps total, so make sure that you leave yourself enough room. If at any point I'm going to fast pause the video, these steps are really important. Make sure you have these steps word for word before moving on to the next page. Step 1 is to arrange the system into columns. Just like before, make sure your x's, your y's, and your constants are lined up. Now, step 2, the important step, the most difficult step, states to multiply one or both equations by a constant so that one variable has opposite like coefficients. Once you've done that, you're going to want to add the equations together and then solve the equation from step 3. If at this point your equation still has both variables in it, something didn't go right. So you're going to need to start the problem over. From here on out, these steps should look familiar. Once you have one variable, you're going to want to substitute your answer into the original equation. You're going to then want to solve that equation, and then lastly, write your answer as an ordered pair. Please pause the video. Make sure that you have all of these steps written out before we go on to practicing solving. Hopefully you have all of those steps written out. Now it's time for us to do some practice. We're going to practice first the most important part, the most difficult part, that change step. The directions here state to change the system so one variable has opposite coefficients, opposite like coefficients, really. Now this is the hardest part and the part that trips students up the most, so we want to practice this first. I'm going to give you a few strategies here, but at the end of the day, you can do this however you want as long as you have opposite like coefficients. So my first strategy is on problem number 1. Look at the y's. They already have opposite signs. That indicates to me that that would probably be a good variable to change. So if I multiply the top equation by 3, I end up with the system that's written on the screen. Notice that I was successful. Those y's have opposite like coefficients, which means I did a great job. Now on to problem number 2. Some students like to always change the first variable, so I want to try that strategy here. I notice that the signs are the same, which means whatever I multiply by, it's going to have to be negative in order to be able to change the sign. So for this particular problem, I'm going to need to multiply this by -2. Sorry, that negative sign is not written there. Let's get that in there. -2. When I multiply by -2, I end up with the system that's on your screen. And I was successful here yet again. My w's have opposite like coefficients. So again, I was successful. Over here now on problem number 3, this particular problem can throw you, can throw many students. All the signs are the same. It's not quite obvious what to do. So a great strategy of what to do for this particular problem, let's eliminate the w's, is to switch the coefficients. So what I'm going to do is I'm going to multiply the top equation by 3 and the bottom equation by 7. Now, why is that negative? One of these needs to be negative in order for the signs to be opposite. I chose to put the negative on the bottom, but you could choose to put the negative on the top. Either way, when you do this multiplication, your W's are opposite like coefficients. So we were successful yet again. So now that we've practiced that change step, let's do this all together. Our directions now say to change the system and solve by elimination. There's 4 problems here. I'm going to walk you through 2 of them in detail, and then I'm going to have you pause the video and try C and D, and then I'll walk you through those as well. So for problem number 1, my first step is going to be to multiply that top equation by 4. I'm going to do that so that my A values are opposite like coefficients. I'm going to go ahead then and cross out those A's because those A's are going to eliminate. Then I'm going to add my B's together. 8B plus 5B is 13B. 24 plus 2 is 26. Solving for B, I get B equals 2. Now I want to go back to the original, the typed equations. At the end of the day, it does not matter where I substitute my values into, but I always like to choose the simpler equation just to make my algebra a little bit easier. For this particular problem, I subbed into the top equation. The A is already by itself and there's no negatives there. It just was easier for me. When I solved this equation, I got A equals 2. Now my last step is to write this as an ordered pair, and this may throw you. This may be your first time seeing an ordered pair other than X and Y. Ordered pairs are always written alphabetically, so A comma B or 2 comma 2 is our final answer. On to problem B. Problem B here, how am I going to start this? I think I'm going to eliminate the Y's. And by multiplying the bottom equation by 2, I end up able to eliminate those Y's. I have opposite like coefficients, so they're crossed out here. Next, I want to add my columns together. Negative 3x plus 4x equals negative 7x, and 10 plus negative 10 equals 0. Now, oftentimes students think they did something wrong here. They think that they have a special case or that something's wrong because of the 0. All this problem is saying is that x is equal to 0, because when you divide both sides by negative 7, you get x equal to 0, and that is okay. Now substituting. Where do I want to substitute into? I happen to have chosen the top equation, but at the end of the day, again, remember, it doesn't matter. When you solve for y here, you get y equals 5, and you always want to make sure that your final answer is written as an ordered pair, in this case 0, 5. Hopefully now you're starting to get the hang of it, and I'd like you to pause the video and try C and D. Pause the video now, try problem C and problem D, then come back and play and see how you did. Okay, let's take a look at problem C. I'm going to go through these a little bit faster because you may have chosen to do the problem differently. Remember, you can do the problem differently and still get the correct answer. I first chose to multiply that top equation by 2. This allowed me to eliminate my y's and to get x equals to 4. Once I got x equals 4, I plugged it into that bottom equation, got y equals 6, and a final answer of 4, 6. Now again, this is just one of many ways. Hopefully you got this correct. If you did not, feel free to write this work down, but I strongly encourage you to not erase your work. Don't erase your work. Bring it to class. Ask a friend. We can help troubleshoot it, but if you erase your work, you don't know where you messed up. Problem D now. What did I do first? Oh, I multiplied the top equation by 4 and the bottom equation by 5. I noticed that the x's had opposite coefficients, so I did the switch scalar method in order to be able to do this. That gives me the equation 20x plus 12y equals 16, and negative 20x plus 25y equals negative 90. My x's eliminate. I end up with 37y equals negative 74, and y equal to negative 2. Remember, choose the more basic equation to sub into. In this case, that top equation doesn't have any negatives, so it's going to make solving a lot easier. I get x equals 2, and my final answer as an ordered pair is 2, negative 2. Now, if you are struggling with this, please, 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 please see me. Go to the mark. Get help from a friend. The only way that you're going to understand this is to continue to practice. So I hope this lesson went well, and I will see you in class soon.